Live from your local news leader, Karina Rubio, Matthew White.
Central Illinois' most accurate forecast with meteorologist Jacob Dickey.
You're watching The Morning Show at 9 on WCIA3.
Welcome back. As always, we thank you for staying with us on The Morning Show, and we asked you a question before the break. What makes a good pot, blanket, or ATM? Well, here to answer those questions about science is Wise Guys Paul Kwiat. And of course, Paul, you know science gives us a different perspective on things, and so you're here to talk about thermal conductivity.
Thermal conductivity, which sounds like maybe it's a kind of a boring topic, but we actually care about it a lot for a lot of different things. So for example, you care if your cookie sheet is going to transmit the heat evenly to cook all your cookies, or you might want to keep something cold, and so you want to have it in something that's not going to transmit the heat, or if you have a blanket, you want that to be a good thermal insulator. So I'm going to start with kind of a fun demo. I have these two blocks that are right here, and hopefully the camera people can zoom in and look at them, and I am just going to put a piece of ice on each of these.
Oh, so not eggs this time,
and
Paul.
we're just going to see what happens. Just try and get this lying flat. There we go. Great, and we see that in fact something quite different is happening with the two. The one over here, the ice is melting right away, and the one over here, the ice is not melting at all. These blocks are, they're both black, they're about the same size, they're both originally were at the same temperature, but nevertheless the ice is melting a lot more on the one on the left than on the one on the right, and that's because the one on the left is made of aluminum and the one on the right is made of wood. So aluminum has a much better thermal conductivity.
Takes in more heat.
Exactly.
Okay.
So we could ask what makes a good thermal conductor, and often the same thing that makes a good thermal conductor is the same thing that makes a good electrical conductor, and in an electrical conductor it's electrons that are moving, and so if you have something where electrons can move, like in this spoon for example, they can carry electrical current, but they can also carry heat basically from one side to the other side. And so we could do a comparison between electrical and thermal conductivity. So if we do the first slide here, great. So in the electrical case, if we have a voltage difference across a material, that will push electrons through, and it's usually electrons. And in the thermal case, if we have a temperature difference, that will push, if there are free electrons to move, those will get carried through. If there aren't, then it might have to go with vibrations instead in the material. But typically, if you have electrical charge moving, if the temperature gets hotter, there'll be more resistance in the material. In a metal, if the temperature goes up, actually because the electrons are moving faster, the conductivity goes up. So if we look at the thermal conductivity, at least for a metal, thermal conductivity ratio to electrical, that will depend on the temperature, but if you fix the temperature, the better the electrical conductor, the better the thermal. And in fact, the next slide just sort of shows that. For a bunch of different materials, it doesn't really matter what they are. On the upper right, we have copper, and on the lower left, we have some other substances. But you see there's a general trend. Depending on what type of material we're looking, the better the electrical conductor. This is all for metals. Coming back to us, but that's also true even if something is not a metal. So if I have something that is, for example, wood, that's not a good electrical conductor, it also doesn't conduct heat very well. That's why we want to build houses out of wood, for example, not out of aluminum. It'd be hard to keep the heating costs down. Ceramic, like my bow tie here today, is also a very good electrical and thermal. That's why you want to make like a coffee cup out of ceramic, so that the heat doesn't go immediately out of it. There's kind of an odd counterexample, which is that it turns out that, which is actually the third slide, it turns out, it's kind of curious, that diamond is an extremely good electrical insulator. So it has almost no conductivity whatsoever, but it's a very, very high thermal conductor. So because it's such a perfect crystal, the vibrations transmit very, very well through it. So anyway, that's kind of a side weird counterexample. Okay, the other thing I wanted to just reintroduce then is our previous, we have this previous camera that we've had that can see in the infrared and see right now, I guess, at the moment there. We can see you and see that, yeah, you're a hot person.
Am I
Great.
a hot guy?
Great. So what we're going to do is a direct test of these blocks that I have here. And I'm just going to pour them off so we can look at the backs of them. And if we just put our hands on these, I'm going to just put my fingers on both of these, both the wood and the metal, and then we're just going to look at it. We're going to see that in the case of the, see if I can. Sorry, this is the metal right here, and I don't really see much at all because my heat from my hand immediately goes away. Whereas if I do the same thing over here on the wood, in fact, I can see my fingerprints because the heat is still there. Yes, so I can see that it's dark. Okay, so what does this have to do with an ATM? So this is not an ATM, this is a keyboard obviously, but it's a sort of equivalent to that. So I want you to just go ahead and put your finger on any one of these things that you want.
Okay.
Yeah, and just kind of keep it on one, for example, so we'll be able to get something. Okay, and now if you remove your hand, we're going to see on the keyboard where you were touching. So if you were at an ATM and pushing buttons, and someone had one of these cameras coming along after you, in principle they could tell which buttons you had pushed. Now, so I do know some people who their solution to that is after they use the ATM, they'll go and they'll push every button, so that if anyone came by with such a camera afterward. I will say it's less of an issue with an ATM. They tend to have metal buttons, and the metal, because it's a good thermal conductor, then doesn't keep that message for very long. And also, typically when you go to an ATM, your passcode is the first thing you enter, and then you're there for another 2 minutes trying to enter other things, and so whatever that initial entry is would probably be dissipated by the time you're done.
So you're saying that even banks will design an ATM based on this conductivity, and
I could imagine that they would. The other thing is that metal buttons, like aluminum has a very high so-called heat capacity, so it takes quite a bit of heat to raise the temperature, a lot more than other substances, and so that means even if you touch it, the temperature doesn't change very much, and therefore the signature that you get on something like this wouldn't be that high.
That'd be scary if someone had that and they went up to ATMs and they could see your IDs.
Yeah, certainly if someone is coming after you with one of these to an ATM, I would be a little nervous.
All righty. Well, Paul, as always, we thank you for your insight and your wisdom. It's
Super
definitely
fun.
helpful information for us science-wise. Thank
Awesome.
you.
Great. Have a great Labor Day.
You too, Paul. Thank you for being here and making the time. And stay with us right here on The Morning Show.